Last time we made a key for a chest lock. Today I'm going to get started on making that lock. This is an old style chest lock inspired by originals that I've seen in galleries in Taos, New Mexico, some books, some museums, things like that. Pretty common style of lock. A lot of the information I'm using to make this lock comes from this book by Mark Simmons and Frank Turley on Southwestern colonial ironwork. I'll try to get a better image of this page, but it's this drawing right here that I want to use as my main resource for making this lock. And you can see some examples that they have in the book here of finished locks. But most of the mechanism I'm using that one image for. Now there's a similar lock in the New Spruce Forge Manual of Locksmithing. This is an excellent resource for locksmithing, lots of information, and I'm going to refer to it as needed for technical information on how things should be done. They have a very similar lock featured in this book. The construction method, the exact details look a little bit different from both, so I'm going to kind of stick with one. And one reason I'm going to go with the Turley book is because I also have this antique lock. I forgot I had this. Every now and then I will go on eBay and buy some antique hardware just as study pieces so I can see how things work, hinges, door latches, locks. And I didn't realize I had one that worked this way. This is a good lock to explain kind of how this sort of lock works. You can see a slot here. When you lock the lock, the bolt slides across that slot. So this then has a hasp, and unlike a regular hasp where a staple comes through the hasp, the staple will be attached to the back of the hasp, and that will engage that so that the staple is trapped by that bolt. Hope that makes some sense. And when you open it, then of course, that'll free that up and you can open the lock. Now originally, I thought this was kind of unique to these New Mexican style chests, Spanish colonial work. But since I started looking at a lock like this, I'm starting to see them everywhere. It's kind of like when you start thinking about buying a new car, the model that you're interested in, you start seeing all over the streets, even though you were never aware of them before. And I'm seeing locks that use the same concept of a hasp that engages through the front of the lock plate on gates and doors and all sorts of other things besides just chests. So it's not an uncommon style of lock, and I think it has a lot of practical applications. Maybe some other day we'll make one and use it on a gate or a door, something like that. Who knows, maybe the shop door when I get it made will feature a lock of this style. But anyways, just looking at the way the spring and the bolt are constructed and assembled, this lock is very similar to one out of the Southwestern Colonial Ironwork book. And since that's kind of what I'm going for, that's my inspiration, I'm going to use that as most of my source of information for this. Of course, my key does not look anything like this. This is a very, very interesting key. The ward is in this tube here that spins, and I don't see that this tube was ever attached to the lock. You're going to put the key in there, spin that until the key lines up, and then if you're lucky, you can get the key in the lock. But it all works. It's a functioning lock, and it's interesting, it's different, and I think that's the key to a lot of these things, is they were made by small blacksmith shops, not by big lock making factories, and not by professional locksmiths. And that's exactly the look I'm going for. So what am I going to use for materials on this lock? I have a piece of 14 gauge sheet metal. This is what I'm going to use for the front plate. Probably what I'm going to use for the back plate. You usually need two to support everything in between. It also gives a place for the back end of the key to engage. For the wards though, I think I'm going to use this piece of 16 gauge that we looked at when we were making the key. And that's 16 gauge. Now for the bolt, my first inclination, because I tend to over-engineer things, was to go with 1/4 inch, be about 6 millimeter. I think that's way too heavy. This lock, the bolt is 3/16 by about a half tall, but this is a much bigger lock for something bigger than what I'm envisioning this for. So I think even that's overkill, so I'm probably gonna go with 1/8 inch. That's more like 3 millimeter. The bar I'm starting with is 3/4 inch wide. When I'm done, the bolt itself will probably be more like 1/8 by 3/8. So it's going to be about half of that, and that gives me material to remove that will engage the key. It'll all make sense before we get done with the video, I hope. Now personally, I don't know if the spring on a lock like this even needs to be hardened and tempered. There's not a lot of stress on it. If you look at this lock, there's a whole lot of material in that spring that wraps around. It doesn't have to move more than about 1/8 of an inch total travel at any point. So probably it can be a mild steel spring. But just to be sure, I'm going to go ahead and use this old spring that I found. This is out of a car door of some sort, I don't know exactly what. But it's probably 1085, 1095, something like that. And should be a good spring for this. And even though this is probably a water hardening steel, I think I'm going to oil harden it. That will keep it from being harder than I want it to start with. And then I want to temper it way back. I'll probably temper this back well into the blue range so that it is just barely hardened at all, and just enough that it's not going to wear out and get soft and sloppy over the years. Probably not necessary. I suspect mild steel would hold up, but I'm not sure, and I don't want to take this spring out of here and spark test it since it's an antique. So those are my material choices. There's not going to be very much forging. The spring is forged. I don't know if anything else on this lock is actually going to need to be forged hot. So there's going to be a lot of bench work. We're going to spend a lot of time right here at the vise with hacksaws, files, and for a little bit of this, a little jeweler's saw. At this stage, I'm just kind of guessing how large I want the back plate. I may cut it down later if it's way too big, but we will see. And I'm making it 4 by 5 inches. So that's just short of 130 millimeters by about 105 millimeters. Again, these exact sizes are totally irrelevant. Make your project work the way you need it to. So how do we cut this out? You could absolutely do this with something like a Beverly shear, do it with a bandsaw, you could do it with an angle grinder and a cutoff disc. There are all sorts of little handheld cold saws out there now. Just about every tool manufacturer makes one. Plasma cutter, shears, doesn't really matter. You just need to cut it out. I'm gonna go ahead and cut this out with a cold chisel because that's about the simplest method you could use, and it's the most affordable. You can make a chisel for this out of a scrap of coil spring. Only gonna cost a few cents, and maybe an hour, 2 hours of your time to make the tool. So if you're just getting started, learning to cut sheet metal with a chisel is your most affordable option. But there's no reason not to use any of the other options if that's what you have available. For something like this, I'd probably go with the angle grinder and just cut it off. That doesn't deform the material like a Beverly shear would, for instance. Now I know I said cold chisel, this is actually a hot chisel. I should have said I'm going to cut this cold with a chisel. Your hot chisels are perfectly acceptable for this. Or at least they should be if they're made correctly. They can work hard a little bit, so it doesn't hurt to heat this up, normalize it, or anneal it. It also can help create a nicer texture. I don't mind the rust texture on this. It actually will give it some more character, but it isn't even. So I'm going to run it through. So I'm going to heat it up and let it scale a little bit. A coal forge probably leaves the best scale texture on stuff like this, but I'm not going to light the coal forge just to do this one little piece. That chisel does leave a little bit of a ragged edge, but it's really pretty simple to go ahead and file that off. Really about all it takes. I'm not trying to file a square edge. The chisel also leaves a little bit of a beveled cut on there, and I like that, so I'm actually going to go reproduce that bevel on the other two corners where I didn't cut it with a chisel. But I'm going to wait and do that after I'm sure I've got this sized right. If I end up cutting this back plate down, then I'm just going to lose any file work I do there. Only reason to file that ragged part off now is so you don't cut yourself on it. Now the bolt, I'm not sure what the travel distance of the bolt's going to be. I need to kind of relate it to the key. So I'm going to cut this extra long, lay out the slot that the key engages first, figure out what that travel distance is, how that relates to the lock. Then I'll lay out the keyhole and the slot for the hasp to engage in the back plate, get those cut before I start making all the other parts. Let's see if I can draw what I'm trying to illustrate here so that it makes a little bit more sense. So the bolt will be cut down and have a couple of little ears here with a slot that the key engages. So the key will come into the keyhole, rotate up and push this. So I need to get this geometry right, whatever that needs to look like, whether it's straight or curved. And the key will then push the bolt this way, or if you rotate it this direction, it'll push it this way. Now to keep the bolt locked, there needs to be a notch that engages the spring. That's really what the spring does. So there will be a little notch in here, and the spring comes down and has a flat spot that catches this, but then a tail that comes down and blocks this, so that the key has to lift up on the spring so that the spring clears that. So the key not only slides the bolt, it releases the spring. So all of this has to work together. All of it has to fit in the right place on the back plate. So I'm making the bolt a little oversized. I'm going to make sure it relates to the key right. Then I'll make the spring relate to the notch that I cut in the bolt and hopefully get all this right. We're going to do a lot of test fitting and trial and error before I actually get to the assembly part. One of these days I need to make an easel for that whiteboard. I'd probably use it more often. So I think I want to start this just by finding a rough center point. This doesn't have to be exact, since I'm sure I'm going to cut the ends off anyways. And that's kind of the arc of the key there. I don't know if that makes any sense, but that's where the key will run more or less. So if I've got that right, the key should push this to its full limit on either side. I don't want it too big or the key just falls off and the lock doesn't operate properly. So I'm probably just going to file this out initially, make sure that seems to work. I may have to find a plate with a hole in it just to put the key in and get it to stay put. But that's my first plan anyways. Just going to waste some of the material with a hacksaw, get it out of my way. So I got some material with a hole drilled in it that the key will engage in, and I'm going to put a little fence to act as a guide so that I'm not just pushing the bolt up and down. So that does push the bolt up. I need to be deeper, but it also slides it. Oh, it doesn't slide it much. If anything, my key may not be as long as it ought to be, but I think we'll be able to make it work if I'm really careful about everything else. So I need to make this a little bit deeper, but I don't want to make it any wider other than to clean up the slopes. So it looks like the actual travel on this is just about 3/8 of an inch. That's not a lot, but I think it's plenty for the purpose that I have in mind for this lock. Perhaps the next version of this, I will make a key with a little bit taller end on it so that it can engage just a little bit further, or you could draw the end of the key out a little bit if you needed to. So next thing I'm going to do is put the notch in here for the spring, and then I'm going to reduce the height of the bolt. The bolt does not need to be 3/4 of an inch wide or 20 millimeters wide. So I'll probably cut it down so it's about 3/8 wide. So that'll be an 1/8 by 3/8 thick on this. And for a simple little chest lock, I think that's plenty strong enough. So that'll be right about in here, and that'll get a nice slope back here. You could probably just file all that in. But I'll make a stop cut with a hacksaw just to kind of have a reference point there and hopefully keep it from going too far. Next thing I'm going to do is I want to cut that bolt down. Still not sure how long I want it, so I'm going to leave it full length. Just means a little bit more work with a hacksaw. This is just a little machinist's gauge, scratch gauge here. And you can set it to about halfway. I'm not real worried about perfectly halfway. Be as accurate as you feel like you need to be. That'll leave a nice scratch line I can hopefully see. Probably lay it out with a silver pencil if you'd rather. You hear that? It's actually starting to rain, which is wonderful because we have about a 1,200-acre wildfire about 3 miles from where we are. They've been working on it for maybe 10 days now, starting to get it under control, but it's still something that we would like to see a little bit of rain, so it helps the firefighting effort. Some of you had asked, so I thought I'd give you a little update on that. And yes, if I wasn't doing this for a video, I would be doing much more of this with things like the portaband, using the belt grinder a little bit. But it is absolutely possible to do this with simpler tools, with hand tools. You don't need a big extravagant shop to make simple hardware items like this. But there is our roughed out bolt. Hopefully that makes some sense. There's still going to be some refining and filing on that. And then trimming it to length once I know how it relates in the lock. So that will go in there somewhere about there. And the key will engage it. I just need to figure out where the keyhole goes and then where the slot for this goes, what the travel distance is, then I can cut the ends off, finish filing it, clean it up. Then we'll start making the keepers that hold this in place. And before long, we'll be on to trying to make wards that actually work with the key I made. Using these angle iron blocks gives me a sacrificial surface that I can file right down to make sure this is straight all the way across. This bolt is definitely too long, but that's going to allow me to fit it just the way I want it in the long run. But I think the time has come to put the keyhole in. I'm going to go ahead and put it centered on this plate. Then I'll adjust the throw of the bolt and the size of the plate after I'm sure everything fits right. I don't want to end up cutting anything too small. And there's also a back cover on here that helps align the key and holds some of the wards, or ward in this case. And that will need to be fit before I start cutting things to their final size. So I think the keyhole is just going to go pretty much centered. Just knock the burrs off of that. I'm going to use a jeweler's saw to cut this out. Yeah, okay, clamping that up is not the best idea. Needs what's referred to as a bench pin, which I really don't have. This is about as crude a version of this as I can think of, but it will help tremendously. This will allow me to hold the saw in the same position and rotate the material so I don't have to pivot around the vise while I'm trying to work. Should be much more efficient. And if I do a lot of these, I'll make a better version of this out of hardwood. Oh, the saw may be too small for this. It's also really easy to break blades with a jeweler's saw. I'll just go ahead and drill that lower part out. Probably would have been easier to start by doing that, just use the saw to connect the two holes together, knock out the waste in between, and then everything else just gets filed to final shape. They do make jeweler saws with a deeper throat. This is the smallest one I could find. I thought it was going to be big enough. I just like the smaller, more compact instead of that big, deep throat that has to swing around to maneuver with it. Yeah, it's painfully loud. A little bit more at the bottom. Okay, that's pretty close. Might need a little bit of refinement. Certainly high-end log makers make these things very precise. There's a bit of a learning curve to develop those skills to really get the fine filing done, the fine work with the jeweler's saw. And as I learn more about lock making, I hope I can refine a lot of those skills. But my goal for this project is to get a functioning lock. I'll worry about pretty in future projects. Now I need some keepers that will hold the bolt in place on the front plate and still allow it to slide through its full range of travel. I think I'm going to make those out of the same material I started with for this. It's that 1/8 by 3/4, so 6 by 20 millimeter, something like that. I'm going to rough it out with a hacksaw and file it to shape. This not only needs the slot for the bolt to slide into, but it needs a couple little tabs that can be passed through the plate and riveted over on the other side, and some little feet for that to shoulder up against. Yeah, it's just a little small, so I can file it to make a nice fit. So the next thing I want to do is cut the little tabs that this will rivet in place with, and I want to leave just a little bit more than the thickness of the bolt, so the bolt isn't pinned in there. And there just happens to be a scratch mark down the center of this left from the manufacturing process, just in the right place. Kind of hard to believe, really. So that's pretty much that. Probably more material on the sides than I actually need. It just needs to have enough shoulder that it doesn't hang up. Not bad. So I need one more of these. I need one on either side. It'll look just the same as this one did. Now I realize I've done a lot of talking throughout this video. That's really just my thought process coming out so I can share it with you, and hopefully you can learn something from that, or maybe pick up on the things that you might do different if you were trying this for the first time. But it's also getting to be kind of a long video, so I think I'm going to go ahead and stop it here, and in a couple of weeks I will pick up with a part 2 of this. And this one will make the spring and the back plate, do the wards for the key and all that kind of stuff, and hopefully wrap it up in one more video. If not, we'll go to a 3-part video. I want to make sure I cover all the details, but I also don't want to drag this out to the point that everybody falls asleep. So I want to thank everybody who stuck it out this long. Thank you for watching. If you enjoy content like this and would like to support the channel here at Black Bear Forge, you can do that through channel memberships right here on YouTube. Channel members receive early access to most of the videos. You can also support the channel through Patreon. Patreon patrons not only receive early access to the videos, they also receive the videos ad-free because the videos are not hosted here on YouTube, and I can run them without the ads over there and generally without any sponsored content over there. But for now, I hope you have time in your day to get out to your shop, challenge yourself, have fun, be safe, wear your safety glasses. We'll see you for the next video.